All right, everybody. So here we're going to look at the solutions to our first test. And what you're looking at here is actually I sat down and I took the test. And this is the way that I wrote my work. Okay, and that's what I wanted you to see. It's going to look like the same way I would have done the problems in the videos. And for any question on the test, we could have found a question a lot like it in one of the videos that I posted, but nonetheless, here it is. Here's the test that you took for test 1. So first question on the test was this one, and it's an integration by parts problem. So I wrote down, what everything was for integration by parts, and then here's the formula I was going to use, and that's the way it looked when I put everything in there. I made a note that I would do that part by the substitution, and that's what I would get. Okay. All right. So there's the first one. I'll go through these fairly quick because the way I'm thinking is if you want to look at a certain part of the solution, you could just pause the video. All right. Second question was also integration by parts. So I indicated, what my integration by parts choices were. I even integrated how you'd find G from G prime right there. That's the integration that would do it. And here's how integration by parts plays out. And from here, by U substitution, we get that. I put my bounds in and we'll get 1 over 4. Okay, so that second problem, first two problems were integration by parts. So we'll see something different in the third one. Okay. Now, this comes from the video series where, let's see, how did I word it? I think I said something like if we have odd powers of sine or cosine. And so when I see this, I'll think if I borrow 1 away from the sine, that will end up being the du, because I can turn sine squared into cosine squared. So I'll get powers of cosine out of all this. And then I'll throw that sine that I'm going to borrow away from that 3 over here, and that will be the du. But here's exactly how that happens. So say I borrow 1 away from here. There's sine to the third power. I'll put 1 sine here and 2 over here. I'll turn sine squared into 1 minus cosine squared. And now you're looking at just a bunch of cosine terms right here. So suppose I multiply all those together. It will look like that. When you multiply like things, you add the exponents. That's how I get that exponent. And here's that part that I was anticipating from the beginning, that if you let u be cosine 5 theta, then your du will be negative 5 sine 5 theta d theta. Well, you got the sine 5 theta d theta over there already. You just need to divide out that negative 5. So doing that sequence of steps turns it into u substitution, which looks like this. With the little simplifying, looks like that. We integrate, we get this. We put our substitution back, and we get this. And you can multiply the 1 over 5 through there, and it's not going to matter. It would have been, or I would have counted it right either way. But that's the kind of work and the sequence of steps we're looking at for question 3. All right, let's look at question 4. For question 4, I made a video about what to do with even powers of sine and or cosine. And there was this identity that we used. I put it on the formula sheet, and I would have mentioned it in that video, but sine squared is 1 minus, well, let's say it this way. Sine squared of an angle is 1 minus cosine of double the angle over 2. So that's sine squared squared. So we're going to be looking at that. So I'll square all this. That 2 will become a 4 like so. And with a little bit of algebra, I'll get this. I'll get another even power of cosine right there. I'll repeat use of my identity. And I'll get down here. Okay. So once I get here, this and that are different u substitutions. I indicated what they are. And this is what I would get from those. I could leave it, or I could multiply it, and so could you. It doesn't matter. I would have counted it right either way. All right, and that's the final answer we get for that one. Let's look at the next one. The one with secant and tangent in it. Remember this one? Okay, secant 7 power 4x times tangent 4x dx. So this will be a u substitution of the form u to a power du. And the reason why I have that instinct from the beginning is because I see, well, I got secant. The derivative of secant is secant times tangent. I could borrow one of the secants away to make my du. It really is like that previous question, like this one. Oh, where was it? It's like this one where if I borrow one away from this sign, that will eventually become my du. All right? Okay. So I'll do that. I got 7, right? So I got 6 and 1. Agree? Is everything still there? Yep. There's 7 secants all multiplied together, just like there were here. But that will be my du. So here's the u substitution. We want u to be secant 4x. Du as a result, 4 secant 4x tangent 4x dx. So I'll have to divide that 4, and my substitution goes in. It gets that way. Factor out the 4 if you want to. U to the 6th power du is u to the 7th power over 7, so I get 1 over 28. U was secant 4x. Secant 7th power 4x plus c. Okay. Remember, I go through them quickly. You can pause, or you can ask me a question. So with this one, there at a certain part in one of the videos, I can't remember if I made a video just for this, but there's a trig identity that we used. Okay, all right, and it was something like this. There were different forms of it. You know, you might see this different ways. I don't know which way I put it on the formula sheet, but it'd be something like this. All right. Okay. Now, so I'll take this and I'll get that. All right. And you might say, well, a plus b, that's 15x, but a minus b, that would be negative 3x. Well, this could have been in the other order. I mean, it could have been cosine 9x times cosine 6x. It could have been something like that. So it really doesn't matter the order that you subtract those. So I'm going to say 3x, okay? And then once you use that identity, you get just straight u substitutions on both of these, all right? Okay, and then if we apply those u substitutions, we get here and there, all right? Okay, the next one was a trig substitution problem. So this one and the one after it was trig substitution. And because of that, we substitute this way. All right. Okay, so say we put that substitution in, it looks like this. And with some factoring and a trig identity, that's what you have under the root. So you got root 81 times cosine squared. That's going to be 9 cosine. All right. So from there, cosine cancels, we'll get 8. Antiderivative 8 theta plus c. From there, getting things back in terms of x, if x is 9 sine theta, if that's the substitution I started with, then x over 9 is sine theta, and theta is sine inverse x over 9. Okay? So it should be 8 sine inverse x over 9. Sine inverse being arc sine. You can write arc sine too. I just realized the one after this was also trig substitution, and I forgot to write it out when I was, I guess I missed that one if I took the test. Oh, well. So for the one that came after this on your test, it was a trig substitution also. But there was one, like, in the videos, I remember working like an identical problem, all right? Different numbers. And so if you're worried about that next one, I can show you the time in the video where you can see that problem. I forgot to do it when I was putting this together. All right, so I guess when I took the WebAssign test, I missed that question. All right, so the one that comes after that, the instructions were specifically to use partial fractions, all right? Partial fractions looks like this. In the videos, that's how I would have worked it out. That's how I treated it. Okay, so no controversy there. And some people came up with really wild solutions to this that did not involve partial fractions that I'm pretty sure they got from an online calculator of some kind. And that's a big no-no in our class. You're supposed to convince me that you can work these problems by yourself. Show me the work. And if you get some work there that has nothing to do with the instructions that I think only an online calculator that shows you step by step would come up with, and that is very suspicious to me, and that is a problem. But here's what partial fractions look like. All right. And for even more details to this step, we can look back in the video, but this is a rough amount of detail that I was looking for. So once the partial fractions are done, then we'll be working on this. And these are each u substitutions of the form 1 over u du, which would take you to here and here. And if you want, you can go to there. If you entered this answer in, it would have been okay. If you wanted to reduce it, that's okay too. All right, I would have counted it right either way. All right, so the instructions there were specifically to use partial fractions. All right. Next one was also partial fractions. I didn't write it down, but the instructions for that one also said to do partial fractions. Now, in order to do that, you have to divide that first. In my video over partial fractions, I said, well, the highest power down there needs to be more than the highest power up there. And if it's not, then we will divide it out first. So if you divide, then, I would want to see this. All right, there's your division on paper. And that reduces what we had in the beginning to this. Now, for this part, you could use partial fractions. Okay, the instructions did say to do that, and some people did it that way. But if you happen to notice that that's already set up for u substitution, that's okay also. You can do it that way. You can let u be x squared plus x minus 2, and the du will be that exact thing up there, 2x plus 1 dx. So you want to take advantage of that, that's fine. And that takes you straight to here then. All right? Okay. Now, the two that came after this, or let me see, two problems came after this that were trapezoidal rule and Simpson's rule. Most people did not miss those. If they did miss it, it was just because of some minor miscalculation, and I ended up giving them some points for that. For having everything right, but just like miscalculating a number, no big deal. You probably got points back for that. The other kind of people that missed it just seemed to not know how to do it. All right, and that's a different story. And so I decided not to work those out in this video, because if you made a miscalculation, I think otherwise you understood it. And if you really just didn't know how to work it, then I would want to take you back to the video where I covered how to do those problems. I think that would be the best way to go. And so I didn't include them here because I wanted to keep the video short, but you saw the big ones, the problems with lots of details and lots of work. You saw them here. If you have any more questions, let me know.